Hey everyone, how's everybody? So in the last video we talked about the installation and kind of basic introduction of Python programming language, and in this video we are going to talk about basics of Python, like how you are going to program stuff in Python. And if you stick to the end of this video, you will find a bonus content. By using today's knowledge, we will be actually I'll be actually showing you a bonus thing that you can do with Python. All right, so let's get started with this. Okay, so first thing first, let me actually recap for what we have learned yesterday. So I told you that Python is an OOP language. Okay, so let us just try to understand what this OOP actually means. So OOP is object oriented programming language. Okay, because essentially what does it actually mean is, just think about water. So water has this property of absorbing heat in a high amount, so the specific heat of water is very high. So technically if you fill anything with water, say a plastic bag with water, then this plastic bag will also have the property similar to water, like it can absorb a lot of heat because it is filled with water. Similarly, in object oriented programming languages, what happens is we have something called as classes. Okay, so classes are nothing but the collection of similar data or methods. All right, so what actually happens is, when you create an object out of this class, say I created an object, so this object will have all the properties and methods of this class. Okay, so essentially all your data types in Python that we have, like int, float, list, and everything else, all of these are made up of classes. Okay, so whenever you create data, like say if I write a equals 10, then 10 is an integer. So what your Python interpreter does is, it stores 10 in a, and it gives uh, the property of integer data types or the integer class to a. Okay, that you can actually find out by typing type a, then it will tell you that what kind of class your a has. Okay, similar to this, say I want to create a floating integer, I write 10.7, then in this case this b is now float type. So whenever you type b, then you will see that it tells you that it is float data type. Okay, so that was a basic introduction. And now as I have already told you that these classes have methods and properties, now whenever you do something like a dot and press tab, there will be a list of properties that you can do with a. Also you can always type dir a, and it will show you a lot of properties and methods that come with a, which is of integer data type. Okay, and similarly if you type help a, it will show you every doc string which is inside integer class. All right, so without a further ado, let's get started with it in a terminal. So let me actually launch the terminal. Let me zoom in. So we are going to actually launch a Jupyter notebook for it. So let's launch Jupyter notebook. Okay, all right, so it has given me a Jupyter notebook, and now we are going to create a new file in Python 3. All right, now I can always write a equals 10, and it will tell me, if I write type a, it will tell me that it is of integer type. Now if I write dir a, it will show me the options or the methods and properties that come with a. Okay, so as you can see over here, we can actually find out the denominator of a, which is the property. So we can actually write a dot denominator, and if we shift tab, then you can see that it tells me it is 1. So let me actually give you a basic introduction as well. So over here you can actually see that I can write a equals 10. That would actually mean I can write it like this. So this is your numerator and this is your denominator. So this is why it is telling me that it has 1 as its denominator. Similar to this, what you can do is okay. So what you can do is you can write a numerator and it will tell you that it is 10, as I have already told you. Okay. Similar to this, we have other options as well, which tells us that it has a conjugate. So conjugate is nothing but the imaginary or complex conjugate of your number. So if you know about complex number, it will be much easier for you. So it tells me that it is a function or the method. So whenever you kind of execute a method or function, you have to always use these round brackets in front of it, because round brackets kind of ask for the arguments. All right, so arguments are nothing but the data that you provide the function. Okay. So it tells me that it has conjugate nothing but 10. So why 10? Because your a can be actually written as 10 plus 0i. So this is in complex form. So its conjugate, that is a bar, will be 10 minus 0i. Well, it doesn't actually matter because it is 0, its imaginary part is 0. So its conjugate will be nothing but 10 only. There is another data type which is complex, in which that would have made some changes, which I can actually show you. So say I create a C, which is complex data type. Now please always remember that in Python we actually write j and not I for imaginary numbers. So say I write 1j. So this will be a complex number that you can actually find out using this type C. It tells me that it is complex. And now if I do something like C dot conjugate, it again tells me that it is a function. So I'll have to actually execute it like this. So it tells me that the complex conjugate of this number is 10 minus 1j. Okay. All right. So let me actually write it over here that we are dealing with data type. So I'll just put a markdown over here, data types, and let me actually write a comment that we are talking about integer and complex data type. Okay. All right. Now let's come over here, and you can always do this bit length. So it will tell you that it is of 4 bit. Okay, integer is of 4 bit in Python. And again, you can always find the other options with it. So by using imaginary, so it will tell you that this has 0 as imaginary part, which we have already seen. And let's see if it has a real part. Yes, it is a real part. It has a real part 10. Okay. Similar to this, we have C, and its real part is 10, and C dot imaginary, if you write, you will get 1, because in our C we have 10 as real part and 1 as your imaginary part. Okay, so it will be much easier if you have a basic mathematics course in your I guess 10th or 11th class. Okay. That will make this thing much easier for you. Okay, now we are going to talk about float data type. Okay, one more thing, everything that you see over here, you can actually find it in the GitHub repository. I'll link in the description below. so that you can practice for yourself. So let's just write f equals 10.7. So yes, so Python interpreter is much smarter. So whenever you write f equals 10.0, it will be considered as integer because it will just remove 0 at the end because it doesn't actually matter anymore. But if you write 10.7, it will automatically convert it to float. You don't have to decide which kind of data type it should be. So Python automatically decides that for you. All right. So if you write f equals 10.7, it will give you again several options which you can always find out using dirf, and over here as you can see we have a lot of options. So this from hex and hex, so I guess you must be knowing about these number system. So Python automatically uses this decimal system. However, it also supports octal, binary and hexadecimal. So I can actually show you how these numbers are presented. So let me actually write number system. So in Python, we can actually write 1 simply in decimal. So this will be decimal, and you can write this in binary like this 0b1. So this will be binary. This is binary, so it tells me that it is 1. So whenever you write any kind of number in Python, say it can be in binary, it can be in hexadecimal, Python will automatically convert it to decimal number system. So as you can see, I have written a binary over here, but I got a decimal number over here. So for kind of confirming it, I can actually write 10, which is 2, I think. Yes, it is 2. So it tells me that it is 2. Okay. Similar to this, you can actually write octal representation of 1, which can be done like this. So this is your octal, and it tells me that it is 1. Similarly, you can actually write hexadecimal. So hexadecimal numbers are like start with 0, then x. So x is hex, then they kind of took the x at the end and then wrote it like this. So you can actually write like this. So this will be your hexadecimal, and this tells me that it is 1. Okay. Yes, so you must be wondering why we have written 0 on the left hand side. So your constants start with 0. So Python interpreter kind of interprets them that if you are starting a number with 0, that means it is a constant. Okay, that's the importance of 0 at the starting of any kind of number. You can also write 0 over here, but it will not matter anymore for decimal, because 0 at the left for decimal doesn't mean anything. Okay. All right, so we have talked about integer and we have talked about float. So I guess you can also find out the properties, like what these actually mean. So we have conjugate, we have already seen. From hex, so from hex actually means from hexadecimal you are converting something to decimal. So hex means you are converting this float to hex. So we can actually do something like x. Let's see. So it tells me that you have to actually write something like this. So this tells me that you can write this number in this format. Okay. So yes, that's what it actually means. Okay. Similarly, you can actually check if it is an integer or not. So whenever you kind of see if a method is represented like is, and if it starts with is, then it technically generally actually means that the answer of it will be in true or false. So this method will return a binary thing which will be true or false. Okay. All right, so now we can actually talk about list. So let's talk about list. So list is a pretty important data type in Python. So you can actually write, let's call it L. L equals, so lists are actually represented like this. So you can actually write any data in it. So it can be a string, it can be float, or it can be simple integers as well. So list is the collection of other kind of data type, or simply it could be the kind of it can be the collection of some other data types, or the collection of list itself. So you can also write several lists inside the list, and then several lists inside that list as well. So the possibilities with Python is endless. So you can do anything that you want. So I can write Python over here. So there is something called as indexing in Python. So whenever you have an iterable data type, so iterable data types are those data types in which you can index the data which is inside them. So over here, if I actually show you, so let me actually take black pen, and let me actually go with 3. Okay, now I'll erase it. So over here, as I have written, L equals 1 2, not 3, it is 4 5, and then Python. So what it actually does is it indexes from left to right. So in that case, in that manner, you can actually hope that 1 will have index 0, 2 will have 1, then 3 4, and then finally 5. Oh, sorry, uh, problem with the number system. Okay, so this will be 0 1 2 3 and 4. Okay, all right. So whenever you write something like L0, so you are actually putting the index in the round bracket, sorry, square brackets. So it tells the Python interpreter that you are asking for the 0th index thing or variable. Okay. Similarly, if you write L1, it tells the Python interpreter that you are asking for this. Okay. Furthermore, if you tell the Python interpreter that I want 1, and you don't decide anything later, but you just write these colon, okay, that tells the Python interpreter you want everything from okay, so let me take this one. So you want everything from 1 to at the end. So 1 to the end over here. Okay, so you want everything from 1 to at the end. All right, so this is what it actually means. Furthermore, if you write L and you don't specify the starting thing, but you specify the ending thing, say if I write 4, then it goes till the index which is this index minus 1. Okay, always remember that. So if we have 4 index over here, then it will go till this 3 index. So it will, since you have not decided what should be the starting, so it will actually take all these values. Okay, so all these 4 values and not this last one. So this last index is kind of skipped. Okay, all right. Similarly, if you write L1 to 4, so you can actually guess what values will be taken in this. So the values that will be taken in this will be this first index, second, and then third, not the fourth one, because we skipped that last index, right? So this was your indexing, and you should actually understand why do we need it, because when we have a lot of collection of different data types in list or tuple, which we'll see in a moment. So if you want to access the data which is inside these data types, then you will have to use this kind of notation. Okay, so let me actually erase everything. Yes, so I actually forgot to tell you one more thing which is pretty important over here, and that should be, let me take this dark violet color. Yes. So if you write something like this 0 1 2 3 4, yes, so it will return you Python. Okay, so this Python is string data type. So whenever you see something which is inside the quotes, like it could be like this, it could be like this, or it could be like this. Okay, so there are three kind of ways you can define your strings in. So these are strings. Okay, so strings are also iterable data types. So what will happen is, say if you want y in it. Okay, so in a string as well, you can do something like let me take gray color. So you can do something like Python, and you can do p is 0, y is 1, p is 2, h is 3, o is 4, this is 5. Okay, so you can do something like that as well, right? Now if I want y, I can write L 4, and since y has index 1, I can do something like this. So this will tell me, or it will give me y, which we can actually do over here. So if I write 4 and then 2, this should return me. Okay, so it is 1 actually, it is 1. I'm sorry, it is actually 1. So it will return you y. Okay, and you can do this way. Okay, so you can do this endlessly if your data is permitting you. Like you can have some kind of this data, like in which you have list inside list. So you can have something like this as well, and if something is written over here, so you can kind of write this and this. So it can be endless. All right, what you should understand is this. Okay, similar to this, there is one more thing that you should understand, and that is these indexing. This indexing can also be reversed for your iterables. That means say if I have this L, so I can also write the indexing in this way, -1. So why -1? -1 will tell me that it is, we are asking for Python. So you can think about it in this way. Let me actually erase everything. Let me actually rewrite everything. Okay, so let me take another palette and let's put blue color. Okay, so we can actually call Python by utilizing this. Okay, so what it actually does is, let us just try to understand. It will tell me that I want this Python. Okay, why? Let us just understand this. So you can think about your iterables in this way. Say I have 1 2 3 and so on. So I will index them like this, 1 2 3. Oh come on, I always forget this. Okay, like this. And then you can also think there is another same iterable placed on the left hand side, and in which you will index like this, -1 -2 -3 and something like this. Okay, that is why the variable or the constant placed at the end of this will be kind of called when you type -1. Okay, so you can actually think about it like this. So I write Python over here like this. I can think that another Python is also written over here, the same data. Then I will index it like this. So let me actually take another color. Let's go with yellow. This is 0, this is 1 2 3 4 and 5, and similarly n will be -1 -2 -3 and similar to this. So I hope that made some sense for you and you got the idea what your iterables actually mean. Okay, now comes what are the methods and the properties which are available in your uh, list. Okay, So you can always do what I have already told you, dir l, and it will tell you that it has a lot of options. So you can take help message, utilize help message and find out what it actually does. What essentially append, clear, copy, count, extend they do is append actually extends or the writes another variable or the constant at the end of the list which you have already available. So yes, so there is another thing that you should understand, and which is let me erase that. In Python, variables or your data, okay, let's call it data types, are of two types, which are first of all which are mutable, and then second is immutable. Okay, so mutable data types are those data types in which once you create them, so we have created this list. So mutable data types are those data types, once you create them, you can change them later on. Like if I want to add anything in list L, I can append, and they actually provide everything in them. So this append is kind of appending everything like this 3 in your list L at the end of it. Okay, and immutable data types are those data types which once you create them in Python memory, you cannot actually change anything in them. So one example will be tuple, which we'll be seeing in a moment. Another example is a string. So strings are also immutable in property. So I have say Python written in Python, or I store it let's say like this a, then I cannot add anything in this or subtract anything from this. There are methods which will do this, but they don't actually change anything in the original variable. They create another variable or another thing at another address or other address, not at the same address. Okay, so that is totally different stuff, and we'll see in a moment that. And another data type will be tuple, which I have already told you that tuple is also similar to list, but the only difference is tuples are immutable in nature. Okay, so where you are going to use tuple or list will depend upon your requirement. Say if you want to kind of create something or write something which you don't want to change later on. It could be say date of birth, which will always remain the same, so you can create it in a tuple. It could be something else as well, say address. Well, address here will be string, so you can actually decide later on. Like, yes, one more example. Suppose if I'm kind of doing some kind of hardware automation. So what really happens is in hardware automation, there are GPIO pins that we technically use in some devices like Raspberry Pi. In Raspberry Pi, there are set of GPIO pins which you won't actually change once you are kind of starting your experiment or you are starting your programming. So those pins, GPIO pins, can be listed in this tuple data type, which you are not going to change anyways in the future. Okay, so that was that about your list. So yes, so let me actually show you what this append does, so that we kind of know. So it tells me that append object to the end of the list, and it also tells me that how you can actually append the object. So say if I want to append uh, say I write anaconda and I want to append it in L. So as you can see, at the end of an L, I have written anaconda over here. So similar to this, you have other options. So we have insert, we have remove, we have reverse, we have sort, we have pop. Okay, so yes, so there are these pop and remove. So there is a slight difference in the functionalities of both. Remove actually removes the object by its name or what is written in it. say I want to remove anaconda, then I'll type remove and this anaconda, it will find the index of anaconda and then remove it. But in pop, what you will actually do is you will write the index what you want to remove, and then it will remove it. So actually this pop will be much faster when you do a lot of operations such as removing, because first of all, if you are using remove, what will happen is it will find out the index first and then remove it. But since in pop you are already know the index, and if you write the index, then it will directly remove that particular thing from the memory or the list. Okay, so let's just try to uh, apply this knowledge. Let's just try to remove anaconda. So if I write remove anaconda, and if I see, I have removed anaconda from the list L. Similar to this, if I want to remove Python from it, so I can actually guess that 0, 1, 2, 3, 4. So 4 is the index of this. So I can actually use a pop over here. So L dot pop 4. So it will tell me that I'm removing a Python from the list, and then you can actually see we don't have Python in the list. Okay, so this was a basic introduction to lists. Now let's come on to the tuples. So in tuples, you will see that we kind of define tuples. Let's write tup equals 1, 2, 3. Okay, now if you write tup and okay, write type and type of tup, come on, tup, then it tells me that it is a tuple data type. And now if you want to know what is inside a tup, you can write tup, and then you will see that we have only count and index as its methods, which are not a special method. Don't go over there, like these are double underscore methods or under methods. We'll see or talk about them in the advanced Python stuff. Okay, so as you can see that we just have count and index. So count will actually count one particular object, the number of times it is coming in your list, and index will tell you the first time that particular object comes in your list. Okay, so that's that about tuple. And say okay, so let me actually show you. So say I want to find out the index of 1. So I write something like this. So it tells me that it is at 0th index. So it is at 0th index, as we can see over here. Okay, now there are other data types as well in Python, which are strings. So yes, so let's write strings as well. Okay, so strings, say let's just write, okay, not str, let's write s only. Let's call it simple string is strings. Okay, so as I already told you that you can index these strings, so I can actually do something like this. S0, this will return me this 0th index. Now there is a lot of functionalities that comes with your strings. The one is string concatenation. So you can also write something like this, string concatenation. What it actually means is, suppose if you are having, so let me erase this. Suppose if you are having two strings, say a, b, and then you add them to cd, so these are two different strings. Then what will happen is Python interpreter will take this and then combine them both in another string. So it will be written as a, b, c, d, something like this. So I can actually show you this. So say I want to write a, b and plus c, d, then it will tell me that I have combined both of them, and it writes them as a, b, c, d. Okay, that's about this. Now strings have a lot of functionalities which you can actually identify from over here, that it has capitalized, case hold, center, count, and it will take me another separate video, at least an hour long, to explain every option available in this. So I want to be explaining everything, but whenever we will be using any of these options, I'll actually explain that option first, and then we'll tell you what we are going to do with it. Okay, so I'm not going to kind of do anything with that. Okay. All right, so after this, now let's talk about some basic Python functionalities which we have already talked about, yes, in yesterday's video. So now let me actually give you some, okay, so let me actually do a markdown, basic functions. Okay. So we have print over here. So print is nothing but just to print whatever is written inside it. So we can actually write hello world, so it will return hello world. Okay. Similarly, as I have already told you, that we have built-ins, and if you do something like this, and it will tell me that there are a lot of options, and in most of the options I cannot even go with them, because as I have already told you, it will take me another separate video to explain each of these modules. Okay, so let me actually just show you about this absolute. So absolute, what it actually does is, if I write -10, it will return me the absolute value of it. So absolute values are actually, if you have a mathematical background, you will know that absolute values are like, absolute symbol is this, like you take two straight lines, and this actually gives you the absolute value, which is 10 over here. Okay. Now you can also kind of call this absolute function by just writing this. Okay, you don't have to write this built-in dot absolute. Okay, so this is always available over here. Similar to this, we have power, we have len, we have range. Range we'll talk about in a moment. Okay, and we have a lot of functionality which is available in built-ins. Okay, so now what I'm going to talk about will be the loops. Okay, loops. So what loop actually do? Let us just try to understand this. So suppose if you want to perform some functionality, say you want to print hello world 10 times. Okay, so what you will have to actually do is, you will have to take this print hello world, and then we'll have to kind of write it 10 times. I'll just go with 4 times. Okay, and only then it will print it this 4 times. But what you can actually do is, you can actually write it in this way. Okay, for I in range 4 times, and then yes, you can write something like this, and it will print the same thing. So let me actually explain what this line actually means. Okay. Oopsie. Okay. So let's go with the red color now. So the column that you're seeing over here, it actually tells the Python interpreter that I am writing another code block. So this is a separate code block that you are going to see below this point. Okay, so so let me actually rewrite it. For I in range 4, and then print hello world. Okay, now let us just take another pen. Let's take black pen. Okay, so this I is iterating over range. So if you write range 4, that actually means that it is giving me back 0, 1, 2 and 3. Okay, so you can consider it similar to a list. Well, it is not list, but you can consider it like one. Okay, Now whenever you write for I in range something, what will happen is this I is assigned the initial value in that particular thing. Okay, now what will happen is this 0 will be stored in I for the first time, and then for ith 0 value, ith 0th value, what will happen is it will print this or execute this code block. So this, as I have already told you, that this means that we are kind of going in another code block. So it is telling me that it is a separate code block beyond this point. Okay, so in we actually denote different code blocks by using this like we use tab to indent everything on the right hand side, so that we can consider it as a separate code block. Okay, so after this it will print for 0th value, then for first value, then second value, and then third value. So it will execute this 4 times. Okay, as you should remember that the indexing is always from 0. The indexing always happens from 0, right? So this will print this hello world 4 times. So this is actually your for loop. This is your for loop. As you can actually see that it is written over here, it says for. Okay, so now we can actually erase everything. Okay, come on. And now yes, so that was for loop, and now let's talk about while loop. So what your while loop does is you can actually write while. Yes, so one more thing, for using while you will have to actually kind of assign a value for your variable that you are going to use with while loop. So say I write I equals 0, and then I'll use while I is less than say 10. Okay, then I'll use this colon. Colon means I'm going to write another code block beyond this point. So it automatically indents it for you. So it automatically understands that you are going to write another code block. So let me just indent it for you. Now say if I want to print hello world, it will print hello world for me indefinitely. Why indefinitely? Because I haven't kind of incremented I, and so it will kind of go for on and on, and it will not stop because I'm not incrementing I. So this condition that you are seeing over here, this is always true. So while loop runs only because this condition is true. Okay, so when I is 0, so 0 is always less than 10, so it will run, and since I have not incremented the value of I, so 0 will always be less than 10, and this condition will always be true, and hence this loop will go on and on. It will not stop. So for kind of stopping this behavior, what you can do is you can write I equals I plus 1. So when you do that, this will run it for you 10 times. Okay, so when it reaches 10, so 10 is not less than 10, it is equal to 10, so this condition becomes false at the end of this loop. That is why you won't get any output at 10. So the output is only till when your I is 9, which you can actually confirm by writing I over here, and to run this code it will tell you that the code ran for 0, 1, 2, 3 and so on till 9, but not 10. Okay, so this was while loop, and we use loops because we want to perform same kind of task again and again, and we don't want to write other code for it. Okay, so that was a basic for loop, and now let's talk about the functions. Okay, so functions are pretty important. So let me actually write functions. So when you are going to use functions, let us just try to understand this. So functions are used when you want to change some data, but you don't want to write that same code again and again. So say I want to write print my name. Okay, so my name is Vedul, so I can just print it. But suppose if I want to print someone else's name, okay, so what will happen is you cannot actually do that over here. You'll have to actually write something like this, print, and say I'll write Sharma. So this is, you will have to rewrite it again and again. But for this kind of purpose, what you can actually do is you can define a function. So functions are actually defined as like this, def. So let me actually call it name, and then they take some argument in them. So let me actually tell you what your functions actually do. Okay, so whenever you define a function, let's say def name, now these functions will take some argument in them, and then there will be a piece of code. So say I kind of write name over here. So what will happen is it will take this name whenever I call it. So say in the main code I call it like this, name, then what will happen is this name, this is actually called as argument, okay, and this is actually called as parameter. Okay, so this will go over here, and it will then do whatever that the code is designed for. Okay, so let's try to understand this. So let me actually write name, and we can actually write something like print and then name. Okay, so now whenever I want to write this, I can write name, and then I can give say the name. I can call it again, so it will return me the same thing, like by changing it. Okay, so name is your object of a string type. Yes, there is another thing that you should understand. There is something called as string formatting. Okay, so yes, so this is pretty important, and I use it always or all the times. So let me actually tell you string formatting. So yes, so string formatting is something like say if you want to kind of put something inside this bracket, say my name is, so now you have this placeholder over here, you want to place something over here. So what we do is we write something like this. We have this like curly braces, these are actually called as placeholders in this strings, and then I can use format method. So format method is in Python for strings. Okay, so I can actually write something like my name is, and then it will automatically will take this value and will send it over here. There is another way which you can try this. Well, there are three ways that you can try it with. So let me actually erase everything from here. So let's just understand the formatting. Okay, so one way to do this will be as simple as this, as I have already told you. So you just use format, and then you define anything, like it could be more than one thing as well, and it will be taken as like whatever that you write, it will be indexed as 0, 1, 2, 3, and whatever that may be, and then these are automatically indexed from left to right. So this is 0, then 1. Then furthermore, what you can actually do is you can manually give them a number. So say I want whatever that is written at the end of it as a first value. So what I can do is I can write 1, and then I can write 0, and then I put format method, and then I write first value and then second value. In that case, what will happen is this second value, the first index, will go over here, which because we are explicitly defining that the first index of format method should go over here, and then 0th will go over here. There is another way you can do this, which came in, I guess, Python 3.5 or 3.6. I don't actually remember that, but now you can actually write f at the starting of the string and say you have already named these variables something. So say I have already named, I saved this as my name variable. So what will happen is I can actually write this placeholder and just write the name of the variable, and in this way it will also be executed in this same way like you are doing this or like or this. Okay, so that was it. So let me actually come out of the drawing mode. Now let me actually show you name equals variable, and now I can actually write like this. And okay, so I can write name and it will return me this middle. So you can actually use this print statement as well, and this will return you the thing. Okay, so it can also be used over here as well. You can actually write f, and then you will have to use this now curly braces. Now whenever you call this function, it will execute in the same way. Okay, there is no other difference. So I hope you got the idea what your functions are for. The functions are for reusing the same code again and again with by changing some parameters, because that is what you're gonna do in long term. Okay. Okay, so now let's talk a little about the modules. So importing the modules. So let's talk about modules. So there is this module called as OS, and also so I told you that you can import several modules. Like there are several ways in which you can import the module. So let me actually show you that. So import OS, and if you write this comma sys, what will happen is you can import both of these modules like this. There is another way. Say if you want to import some specific thing from OS module, so what you can actually do is from OS import, say make dirs, make directories. So you can import that like that as well. Okay, now whenever you want to call this make dirs, you can directly call this like this. Okay, like this only. Now okay, there is another thing that you should understand is say if you want to import everything from OS module, so what you can do is from OS import star, that would mean import everything from OS module. Another thing will be say OS has sub modules. So what you can actually do is you can import from OS dot the name of submodule import something else. Okay, in this way you can also import. But now you may ask, what is the difference between like importing all the variables or importing just the OS? What will be the difference? So the only difference will be in this way. When you import everything like this, what will happen is you will kind of call every method or function which is available in your OS module like this, OS dot, and then you will call them. But in this way, the way you are seeing over here, you can directly call those modules. Like you can directly call make dirs, okay, make dirs, and something like that. So that's the only difference. There is one more thing that you should understand. This is not always the best way to import your modules, because whatever that you import in the memory will take up some memory while you execute your program. So if you are running on low memory, such as on your embedded devices, it could be your Raspberry Pi, which has low memory, then this will not be the way in which you should import your modules. You should always import your modules in this way only, and that will make sure that your least amount of memory is taken while executing the same task. Okay, All right, so yes, so I guess this was it for this video tutorial, and now let me show you the bonus content. So now the bonus content. Okay, so let me actually create a single file. So name.py, let's just call it name.py. Now maybe you wouldn't know, you can directly give the variables or whatever that you are writing directly from the terminal. Okay, so say I want to print out my name. Okay, so I can import this sys module. Okay, sys module. Now I can write print my name is, and then I can okay, so I can actually put my name like this, name equals sys dot arg v. Okay, so I can write say it will be, I guess, first index, no, it will be second index. So I can uh, put it like this, name, and then write something like this, like that, and then let's go out of it. So python name dot py, and then let's write my name over here. So it tells me that the reason is I didn't think about what will be the number of variables in my code. So what you can actually do is you can do something like this, save it, relax, now run the same code. Now my name is Vidul. So this sysargv module takes your arguments from the terminal itself and kind of sends them in your code. Okay, so that you can actually use in your, this can be actually used in a lot of ways. In future classes we'll actually see uh, that as well. Okay, so I hope you did enjoy this video, and if you did, then give me a thumbs up, and if you are new to my channel, then you should subscribe to it. So thanks for watching, and I hope to see you in the next one.